in the thymus, and that's why the name T cell is. They are thymus-educated or thymus-derived cells. These are the bone marrow mature cells, so they are the B cells, okay? Is that clear? Okay. And again, this you are not to worry about anything. I'll give you the punchline. If this was the stem cell, that it goes through a number of series of processes of maturation, whether they go within the thymus or in the bone marrow, depending upon T or B cell. And once they are set to the stage that they are very close to the maturation, that gives the sense, a sensor to the bone marrow or the thymus to release them and go in the periphery in our blood. And from our blood, they go and home our lymph node, the spleen. Those are the two major organs. And it is in the lymph node that most of the action of the immune system takes place, not in circulating blood. So all our immunological responses, how we make antibodies, how we make T cells to be killer cells, it all takes place in those lymph nodes and the spleen. And so up to this place, when they are in bone marrow and thymus, they are literally in a sterile environment. They do not come across any microbes or any antigens. And so that's how you should remember, okay? And in the B cell, that stage up to this, again, you are not to remember. There are a number of genes which are required to rearrange in order these B cells to mature. And therefore you can think about it, there will be immune deficiency of those all genes. And so you won't have those cells. And those are very, very severe diseases, you can imagine. And fortunately, none of you have any of those. And so if we take, so here if you see the cells which are released in the blood and go to the lymph node, they can make only one class of immunoglobulin or antibody. So here, after they have released in the blood, what happened? So if you see here, these are the naive cells because they have not been exposed to any microbe, any antigen. So when they come in the blood, they are absolutely naive, okay? And now they come in the real world and they are challenged by various antigens. So what happened? So the next slide gives you, once they are released in the peripheral blood. So now here they come across whatever microbe or whatever antigen it could be. And since it is foreign, those B cells become a little more activated. They respond to it. And then the second step is that they divide because they want to make an army of these cells in order to generate enough of the response to fight that infection, for example. So up to that time, it is all IgM type of antibody that they can make. But that's not the only type of antibody we have. We have a G, right? You know, we have A, we have E, forget about D, okay? So those are the 4 antibodies. So what this cell has to do is, it has to switch to make M, or make G, or switch to G, or A, or E, right? So there's a switching takes place. So some of these IgM cells will remain as IgM, some will switch to G, some will switch to A, and some IgE making B cells. So this switching process is regulated by a number of genes. You are not to worry about it, but the T cells are very important in this process of switching. And therefore you can imagine, if there is a defect here in the switching, the only thing you can make is M, no other immunoglobulin, right? Because it has not switched to G, A, and some of you have that disease, and we'll come back to that. But now you see, the very important thing is, when you get the switching in all these cells, they do not produce very large amount of immunoglobulin or antibodies. In order to do that, those B cells, IgM, IgG, IgA, or IgE, they have to further differentiate or mature into another cell, which we call as a plasma cell. And these are the cells really contribute to all those your blood levels when we measure of IgG, IgM, and IgA. So the B cells themselves don't make that much. It is these plasma cells that make, and they sit in our bone marrow. And so, for example, we come across a microbe that make the antibodies with the plasma cell. They are sitting, they have the memory for that, and they will keep making those antibodies throughout the lifetime. So this process of going from B cell to the plasma cell in order to make antibody, it is regulated by a T cell, which is a helper one, and a T cell which regulates, which says no. So it is a balance between the two of them. So that's why we can keep making those antibodies. So it is very, very important to remember. Therefore, when we examine your blood, sometimes you may not be making this antibody, but still you have the normal number of these cells. But the problem is they don't become the plasma cell, so they can't make antibodies. Is that clear? Yes or no?
Yes.
Okay. So the G has further 4 components: G1, G2, G3, and G4. And some of you have that selective IgG subclass deficiency. Okay? So the G1 is the most common one and most in quantity, followed by G2, G3, and G4 is very tiny. And if you look at what they do, the G1 and G3, they respond, or they make the defense against the bacteria which has their outer covering as of protein. For example, mumps, measles, diphtheria, tetanus, all those are examples of bacteria containing proteins. Whereas the 2 is more with the carbohydrate, the bacteria containing the covering of the carbohydrate, just like pneumonia bacteria. So depending upon those deficiency, you can have a different type of infections. Okay? So what are the function of antibodies? So we talk about antibodies, how the B cells mature, how they have to differentiate from B cell to the plasma cell to make the antibody. But what are the function of antibody? So there are certain functions of the antibodies that they themselves can do. One is they can neutralize the bacteria or the viruses, or they can neutralize the toxin produced by them. Okay, that's one function. Antibody can directly bind to the microbe or to the toxin and neutralize it. The second thing is that the antibody can bind to the bacteria, and then it can help the cell which has a capacity to ingest the bacteria, So it opsonizes. It is like icing on the cake. It is easy to ingest with the icing on the cake than the cake itself. So the antibody provides that icing. So it helps those cells to eat bacteria, and therefore these cells will be able to kill it. And then it can also, these antibody can coat those bacteria and ask these natural killer cells to kill them. So one sort of the function is that they can do themselves. In other, they need a little help. Remember the complement I talked to you, because they complement the function of the antibody. So they will, in a sense, activate those different components of the complement. And what it does, it further helps to phagocytose or ingest those bacteria, what antibody alone would have done. So bacteria alone can be ingested, antibody help them. If you put the complement on the top, it further helps it. So it is complementing so antibody is using complement to amplify its function of phagocytosis. It can also, the complement has capacity, once it gets on the surface of the bacteria, it can punch hole and kill. So through antibody through the complement can lyse the bacteria. Okay, so here are those four major type of immunoglobulin. Remember, the G is the largest one. And the G is present in our blood and it is present in our tissues. Okay? This is the one that the mother gave immunity to the newborn child. This is the only immunoglobulin that passes through the placenta. No other immunoglobulin. Okay? And we already talked about its function. And you see half of it is destroyed in our body in 21 to 28 days. That's why you get those infusions every 3 to 4 weeks. So that's the reason. Okay? You have 4 subclasses of IgG, 1, 2, 3, and 4. And remember, 3 is the only one. This 21 to 28 days is good for 1, good for 2, good for 4. The 3 is the one which has only 7 days half-life. So some of you have IgG3 subclass deficiency. You get every 2 weeks of infusion. So IgA is the one which is like 2 of the IgG put together, and then you have this piece. And this is predominantly present in the secretion, the bronchial secretions, gastrointestinal secretion, genitourinary secretion, and the breast milk. So it is in the secretion. And this joining thing is the one that confer resistant to this molecule from all the enzyme we have in our intestine. If this was not the case, if we take the oral your IgG, it would be broken by those enzymes into pieces, and that's why we can't give you the oral immunoglobulin. Okay? IgM is the first immunoglobulin, first time you get the infection. IgG is the memory one, IgG is the first one, okay? And then Ig is mostly for parasite.